So the last review topic we need to hit talks about exponents and logarithms. First, I just want to run through all the different properties of exponents. Also, if any of you owe me any late work, it's due. Thursday's the last day you can turn in work for this chapter and get credit for it. So if you're not sure if you owe me something, I can check. I think most of you are pretty well caught up. Okay, what is anything to the 0 power? 1. Any number to the 0 power is 1. The second one, I have a typo. I don't mean that to be x minus, I mean that to be negative x. Sorry about that. What does a negative power do? Change floors. It puts it as 1 over a to the positive x power. Okay, third one. If you have a fraction, how can you rewrite that? You're thinking subtraction. If I when you have a fraction, it turns into a radical. The denominator goes outside your radical. And the numerator, it can either go under or outside, whichever way you want to write it. Okay, a to the x times a to the y. What do you do with those exponents? Add them. That's a to the x plus y power. Next one, if I have a to the x over a to the y, so if those are divided, then you subtract your powers. A to the x times y, power to a power, we multiply. And the last one, if you have one term in the parentheses, so as long as those things are multiplied together, you can distribute your exponent to both of them. Questions there? So I just want to do some problems, simplifying things with exponents. All right. First one. We have to start with this cube out here, and it goes to both of them. So 3 to the third would be 27, and that would become x to the 6th. Then we can multiply those, and we get 27x to the 10th power. Next one. Start on the numerator. If we are multiplying, what do we do with those exponents? Add them. So 2n plus 3n would give me a 5n minus 1 over x to the n plus 2. If we are dividing, what do we do with our exponents? Subtract. So I have to do 5n minus 1 minus my n plus 2. So if we distribute that negative, combine like terms, 5n minus n is 4n, negative 1 and negative 2 is negative 3. So we get x to the 4n minus 3. Any questions on those? Alright, I said 8 to the 4/3. I need to rewrite that how? Cube root of 8 to the 4th. I would rather do the cube root before I do the 4th power. Cube root of 8 is 2. And then 2 to the 4th would be 16. All right, D. Let's start with that parenthesis. What do I have to do with it? Put it on the bottom. That whole thing has a negative power, so that whole thing drops down. And it becomes a positive 3. Okay, from there, we can start simplifying. If we have that power to a power, we distribute it. So that becomes 5 squared, or 25, x to the 8, over 3 to the 3rd, or 27, x to the 6th. Right, working on the top, if you multiply those, 5 times 25 is 125. X to the 0, you could even just drop that because it's just a 1. Or if you think about it, if you're multiplying those x's, you add their exponents. 0 plus 8 is just 8. Can we simplify anything? My numbers don't reduce, but my x's do. I have more x's on top, so it ends on top. 8 minus 6 is 2. Do you guys remember doing these before? Yes. Because it's like canceling them. X to the 8th is saying essentially you have 8 of those on top. X to the 6th is saying there are 6 on the bottom. So if we do that, we can cancel out 6 of them and you're only left with 2 on top. So when they're dividing, you subtract the exponents and you'll only have it on either the top or the bottom, wherever there were more to begin with. Other questions? try a couple more. Okay, so starting point for E. What do you want to do? There's not just one correct answer, but give me an option. Okay, both of them have a negative exponent, so we could change floors on both of them. So the 4 cubed will go down to the bottom, and 2 to the 8th will come up to the top. Okay, we could simplify here. What is 2 to the 8th? What is 4 to the 3rd? What's 256 divided by 64? Anybody with a calculator can help with that? Just 4. F. What do you think here? Do you like having the radicals? Okay, so let's write it without the radicals. A square root is like what power? 1/2. So we had an x times, and then I had another square root of xy, so that would be an xy to the 1/2 as well. So this 1/2 on the outside went with the big radical that was over everything. Then we also had an xy under the radical, so I put it to the 1/2 as well. Right, on the bottom, a 4th root is what power? 1/4. Okay, now what? Take a place and let's start, guys. Just have to start applying these exponents. Let's work on the inside. So I have to distribute that 1/2 to each of them. On the bottom, power to a power will be multiplied, so 3 times a 4th will be 3/4. 5 times a 4th will be 5/4. Okay, if you want to keep working inside, this is the next to the first, so to multiply those you add exponents. 1 plus 1/2 is 3/2. Have I lost anybody? Let's go back to the top. Let's distribute our 1/2. So we have to multiply it with the exponents there. So 3/2 times 1/2 would be 3/4. Y to the 1/4. What happens to my x's? They cancel. It's the exact same thing on top and bottom, so that's fine. My y's, we can subtract. Do you have more on the top or the bottom? Bottom, so it will end on the bottom. 5/4 minus 1/4 would be 4/4, which is just 1. So we end with 1/y. questions for me? If I'm going to graph an exponential function, so that's like 2 to the x, 3 to the x, 4 to the x. If you remember from your previous math classes, we always use the same points. Any graph, you know I like 3 points. If you're graphing something with a number to a power, we had to use x equals what 3 numbers? Remember? -1, 0, and 1. Those were the 3 points that we needed that would give us the complete graph. So let's just practice a couple graphing examples. So we are going to graph y equals 3 minus 2 to the x and get the domain and range. That's the same thing as saying -2 to the x plus 3. So you guys know I'm big on parent functions. We did transformations in the last section, so let's do parent function and transformations here. My parent function is just my 2 to the x. So the 3 points we have to put in, -1, 0, and 1. If you put in -1, 2 to the -1 is 1/2. If you put in 0, 2 to the 0 power is 1. And if you put in 1, 2 to the first is 2. Parent function, I like dash, please. Remember, these had a horizontal asymptote because will you ever do 2 to a power and get 0 or a negative number? No, they just approach the x-axis. Okay, now we know how to do transformations. What does the negative do? Flip over what? It's like making all your y's negative, so it flips it over the x-axis. And then what's that plus 3 do? Up 3. The thing you have to watch on these is if you move these up or down, it does move your asymptote with it. So my asymptote was at 0. Where is it going to end at? Positive. So now let's move each of our points. So if I flip this, it goes here, then up 3. Flip this, we go down to -1, then up 3. Flip that, goes to -2. Up 3. Domain. This extends both directions, left and right, so the domain is -infinity to +infinity. The range, you go bottom to top. So this is coming from -infinity, it stops when we get to 3, but we don't touch the 3. So the 3 gets a parenthesis. You guys do this one. So parent function is 3 to the x. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. So there's your parent. This graph is moving down 2. So your horizontal asymptote ends at -2. Move each of your points down. Oh, that's really bad. Hopefully you drew yours a little bit better than that. Domain, every time on these is negative infinity to positive infinity. Your range, this one starts at -2 and goes up. So -2 to infinity. Any questions on that? You guys do okay? Let's say I gave you an expression with an exponential in it and asked you to find the domain. So we've done domain problems. We have rules for our domain. We know if it's a fraction, the denominator can't be 0. If it's an even radical, so like a square root, a fourth root, whatever's underneath has to be greater than 0, greater than or equal to 0. If it's a logarithm, the argument has to be positive. This is a square root, so even radical. So the thing underneath has to be greater than or equal to 0. If you add your 2 to the t over, one is greater than or equal to 2. Okay, let me ask you a question. T to what power equals 1? 0. So you could rewrite this 1. It's just like saying 2 to the 0. We drop those bases saying 0 is greater than or equal to t. Or that means t is less than or equal to 0. So our domain would be negative infinity to 0. Let's say I put something like this on test and you got really confused. What's another way you could figure out your domain? Graphing. You have, well, we don't have graphing calculators on test, but on homework, if I gave you a complicated one that you couldn't work out, you can use a graph to assist with that. Any questions on that? We're going to solve some more of these equations in a minute too. B. It's a fraction, so we know the thing underneath, the denominator, cannot be 0. So e to the t cannot be 1. Well, 1 is the same as e to the 0 power, so it's like saying t cannot be 0. So your domain would be negative infinity to 0, union 0 to infinity. So e to the x is the exponential function we see most often in calculus. It's the natural log or natural exponential. More commonly, we're going to look at logarithms, and we see that ln, the natural log, is the one that we use the most often in this class. It has all the same properties. That e is just a number, just like pi. It's like 2.7, and it's got one of those decimals that never ends. So don't panic if you see that e in your problem. It's just representing a number. All the same properties are true. Anything we've done with the other exponentials, we can do with it. All right, you guys, we have two choices. I've got some logarithm stuff, not a ton. Do you want me to stop for the day and just cover the logarithms tomorrow and you guys watch the video, or do you want me to teach as much as I can today while you're here? You guys pick. You want me to stop or keep going?
Just teach it.
Teach it? You guys okay with that? See if we can get through it all while you're here. So let's talk about properties of logarithms. So a logarithm is kind of like an exponential. It can be rewritten as an exponential. Remember, you start with the base. The base of the log is the base of the exponential. So that's saying a to the y power equals x. So we can go back and forth between the two notations. If we have the log of two things being multiplied, you can split them up. Log of the first plus log of the second. If they are divided, you subtract those logs, so log base a of x minus log base a of y. You guys remember seeing these before? This next one, if you have an exponent, what happens to it? Goes down to the front, becomes a coefficient. The common log is just log base 10. So if you see a log written without a base, that means log base 10. We just don't put it. The natural log is log base e, and we write ln. And you'll never see me write it like this, but that means just log base e. So when you see that ln, that's talking about log base e. I want to answer any questions you guys have about your quizzes. So I've given you the properties of logs. All I have left are three examples. So there'll be a short video tomorrow, and then the majority of class tomorrow, after I finish those few examples, will be time to work on the homework or the study guide. So I will have my Google Meet open. If any of you have questions, you can just pop on there and ask me. You can use the chat feature. I don't always sit and stare at my computer, so you might just say, hey, I sent you a message, so I come and look at it. I'm happy to work out problems from either the study guide or this. And if I work any problems in class, I will record those and post that in the recording. So when I see you Thursday, you'll turn in the topic F handout that I'm getting ready to give you and your study guide. Does that sound good to everybody? And you will have a test. Trade-off is you won't have anything to do on Friday. You'll get a free day. Take a look at your quizzes and see if there are questions for me. I tried to kind of mark what you missed. Anything you want me to work out or answer off your paper?